what I'm going to talk about now would be LANDFIRE's reference condition modeling. And the basic idea here is to define the challenge that we had many years ago and go through brief methods of this. I'm going to introduce an example biophysical setting that Corey is going to build on later. And then I'll open and tour Syncrosim. The picture is kind of pointing to maybe a hint at the biophysical setting, the Sage Steppe. I mean, this is probably not Sage Steppe, but it's the only picture I had of Sage. So that's why the picture.
It is. No, it is. You're
is that
on.
Sage Steppe?
Yeah, it has too much grass for sagebrush semi-desert. That is a classic sagebrush steppe. And you notice the hills, the volcanic hills. That's the Snake River Plain right there. So you're in the good spot.
Beautiful. Well, glad I got that. I think I just, hit my Google Photos up and typed in sagebrush or something, and no, it didn't do that. But anyways, back to our flow chart for hopefully a little bit of grounding. As I mentioned in our flow chart on the left, we have our main inputs that with some computing lead to vegetation departure, or VDEP. One of the key ingredients for LANDFIRE's vegetation departure are our reference condition or biophysical settings models. That's where we got our reference percents per succession class. So the challenge we had, and I'm just going to own the word challenge, it was just definitely not easy. We needed to, among other things, document natural disturbance regimes. And I'm imagining that the chat is kind of going off the wall. Where'd you get that? What are the sources of that? Exactly, super difficult. We needed an estimate of how much of each succession class there would have been under those natural disturbance regimes. And then, something LANDFIRE tries to do is use consistent methodology across the country so that we can compare regions, we can compare states, that we can compare watersheds. And so we tried to follow a standard set of modeling rules for each biophysical setting. And this picture there sort of is a nod to the alcohol that was consumed in this process by some people, maybe including myself. Briefly, our methods were something like this. NatureServe gave us a list of ecological systems, and that should be capitalized, capital ecological systems. A lot of them. We largely, the Nature Conservancy's LANDFIRE team worked with hundreds of experts across dozens of workshops across the country to describe how each biophysical setting looked and functioned prior to European colonization. Then, amazingly worked with all these experts to literally in workshops often build the state and transition models. So the picture there is just indicating the excitement that we had doing this, and also just the maddening experience of it. A lot of stubbornness, illustrated by the donkey there. Yes, Rosie is very stubborn. It was incredible. Some of you were there, and we still are greatly appreciative for your work. I want to say, like, your service. It was really hard doing this work, and also a real privilege to get to be a part of it. So this is our example biophysical settings, and Louis, you probably didn't know you're going to be featured this way today, but here you are. We're going to be talking about the Center Mountain Basin's big sagebrush steppe, and you've probably already learned from my comments with the cow picture, this is not my area of the world. Luckily, Corey will be digging into this in more detail. But in these workshops, back in the day, we had an access database where people literally typed in information such as that you see here. And then using a Python script back in the day, again, we built these Word documents. And I think they were actually PDF documents back in the day. And they range from 5 to well over a dozen pages, depending on how much effort, how much knowledge there was of each biophysical setting. You'll see some just example information here of the geographic range. Also, the biophysical settings description documents have several components, such as a historical disturbance regime description. There's a table that was of the fire regimes outputted from the modeling software. There are descriptions of all the succession classes and lit lit review that was brought in for the actual describing and modeling. In terms of sources, I just mentioned literature. We also used a lot of expert knowledge. If there were local data sets on insect disturbance regimes or dendrochronology work for fire scar records, we brought that in. And as Jim nodded at, and as was discussed in the chat, we did include Native American management as a disturbance that was considered in our natural disturbance regime. And then we're working to learn how to respectfully fold in more indigenous knowledge into these documents. I also mentioned we say a lot about fire, but those disturbances could have included beaver herbivory, could have included drought, could have included bison wallowing, passenger pigeon, effects in the Midwest. If we didn't include that, we should have. I believe I've seen that. So anyways, it's not just fire, but it was limited to natural disturbance regimes. So digging into this SAGE step a little bit more, there's a quote from the document about the climate and dominated by perennial grasses. The blue bunch wheatgrass sounds beautiful to me. I don't think I've ever seen it. And then the disturbances that I saw in the document included fire, drought, and Araga moth. Wow, I can't say that. And then there's a depiction, a picture graph, if you will, of the succession classes. Pretty sparse ecosystem in my mind, coming from the east, dominated again by the herbaceous and shrub types. I don't think that trees were at all a reference life form in this biophysical setting. So I'm going to hop on to Syncrosim in a moment, but a couple of comments here before I do that. The modeling in the original workshops was completed in Vegetation Dynamics Development Tool. You may remember that, so I wanted to nod to that tool. We've migrated to Syncrosim, which is developed by a company called Apex RMS. We'll send the link out for this. It's open source software used to structure data, perform calculations, and forecast outcomes. The functionality that I'm going to be showing is like super elementary compared to what can be done in the software. So I just wanted to highlight that. And quickly, as I open up Syncrosim, any questions so far? And I'm going to go check out the chat, see if there's anything there. Okay, thanks, Sarah. Thanks, Sarah. Yeah,
I didn't see anything, Randy, in the questions.
Okay. Okay, great. And are you seeing Syncrosim?
I am seeing Syncrosim.
Okay, great, great. Okay, behold Syncrosim. When you open up Syncrosim, it looks almost agonizingly blank, right? If you're a person who doesn't like a blank screen or blank piece of paper for your work, this is what you get. Though behind the scenes, there's just incredible amounts of functionality. And because of the way Syncrosim is built, you can have packages. For example, there is a LANDFIRE biophysical settings reference condition model package that bundles up all of the LANDFIRE reference condition models and has some additional tabs that, for example, have the succession class descriptions, so that while you're modeling, you can reference those and get an idea of what the succession classes look like. Because you'll see when I open up our sagebrush model here, when you first look at the model, it looks like this. So these are the 3 succession classes, and they have very generic labels. They have early, mid, late, and those can go early 1, 2, 3, mid 1, 2, 3, late 1, 2, 3. We also had very generic kind of structural labels, open, closed, and all. And those are very, very user defined. So one ecosystem may have tree canopy cover as 50% designated the difference between open and closed. Another biophysical setting might have 70%. So they are literally just generic labels. You'll also notice the numbers 0 to 19, 20 to 39, and so on. Those are the stop and end time steps for the model. And I use the word time step, which is kind of funny, but this is sort of a unit list. You have to define the units. In our work, those are years. I mean, you could model tooth plaque if you wanted to using the software, and then maybe the time steps would be in minutes or hours. The framework is very open-ended that way. If you want to model tooth plaque, I would love to talk about that. I've been wanting to do that with students, thought that would be fun. But also the lines, we have green lines indicating deterministic pathways or succession. That is what happens to a cell if it's not disturbed by the end of the time period. Then the blue lines indicate the probabilistic, or most of us would think of just disturbance pathways. So I'm going to double click on a box and open up this mid one open and show you what's there. Across the top, we have that succession pathway. So if the mid one open is not disturbed at the end age of 39, it will move on to late one close. However, we do have these disturbances. We have a replacement fire disturbance, which would send the mid one open class to early one open. So the modelers would typically draw out on paper these pathways and label the disturbances. And then it took us all a little bit of time, at least for me, I'll speak for myself and some others, that we typically think of disturbances in terms of a return interval or the number of years between that disturbance. For the modeling software, we converted those return intervals into probabilities by dividing 1 by the return interval. So if we divided 1 by 100, we would get this 0.01 probability of this disturbance happening in a time step, which is a year for LANDFIRE. You'll see that there's wind, weather, stress. That would indicate, in my mind, drought. I didn't look at it in detail, but and I'm also going to do this and show you the other disturbances that we have pre-populated in the LANDFIRE models. So we have optional 1 and 2, which might again be that passenger pigeon or the beaver, herbivory, the bison wallowing, that sort of thing. Though there is native grazing, which might be different from wallowing of bison. So I'm going to close this now. And I'm going to talk about how we ran the models. I mentioned that we had rules, and I don't know, I can't zoom in here, so I apologize. The text is really small. When we ran the models, we ran them for 1,000 years. And this is not saying that we ran the model from year 301 to 1301. It's just running the model for 1,000 kind of abstract years prior to European colonization. Also, we ran the model for 10 iterations and basically took the average of those outputs. Further, we have initial conditions. So in LANDFIRE, because we were looking to find out how much each succession class there was per biophysical setting, that indicates we didn't know how much there was, right? It's kind of obvious, but we had to populate our initial conditions with something. So we spread the cells out with equal proportions, right? So if we had 5 succession classes, which was the maximum for LANDFIRE, it would be 0.2 for the relative amount at the start of the model. The beautiful thing about these models is that they run fairly quickly. And I'm just going to do that. I'm going to take a chance here. I may regret this, but running the model for 1,000 years at 10 iterations, not spatial, and for 1 biophysical setting, it goes fairly quickly. Before our work today, I made I pre-populated some charts, so we can open those up. So this is a representation of the state class proportions at time step 1,000, an average across those 10 iterations. And a note that you should be aware of, the y-axis is free or fluid, meaning it changes from chart to chart. So this one starts at 0.2, goes up to 0.5. So be aware of that as you're interpreting these charts. So for the early one open and late one closed succession classes, we estimated based on natural disturbance regimes that there would have been roughly 25% of that biophysical setting in each of those succession classes, and roughly 50% in the mid one open. I'm going to close this chart and open a couple more. We can also track those succession classes across time. I wanted to show you this one because you'll see how you get this kind of equilibration after time. So we had an initial condition, initial proportion of 33% for all these, or 0.33 for all the state classes. And then they equilibrate over time. Depending on the disturbance regimes, it could take longer than it did for this one. But I found that for our work, 1,000 years is sufficient to get this this equilibration over time. And I'm noticing the chat. Yeah, it'll be fun to discuss more of this in a moment. All right, so with that, I'm going to open up the LANDFIRE package really quickly and just give you a tour of that because it's super useful. Across the bottom, I'm going to zoom in just for fun. This is, I believe, a biophysical setting out in Corey's neck of the woods in Oregon. Across the bottom, you see all these tabs. Each one represents its own biophysical setting. Excuse me. So, over 900 tabs here. Also, I wanted to click on this LANDFIRE tab and show you that within Syncrosim, we have the succession class descriptions that were imported in by Apex for us. And you can filter these. You could even export this data set into a CSV file and do work with it there. Also, we have all the succession class mapping rules, which are the combinations of height and cover that give us the succession classes when we map them today, which Corey will be digging into more later. So with that, I'm going to stop sharing and be available for discussion and questions.
Randy, that last thing you showed, was that the package you were talking about earlier?
Yes, the
top there?
LANDFIRE
Okay,
package.
thank you.
Yep. Any questions or comments on any of that? Amy, I want to further comment on your question for installing Syncrosim. Right now, there's Syncrosim Cloud, but it's not everything. It's not everything we want it to be just yet. But you can explore outputs in the Syncrosim Cloud interface. So if you wanted to, for example, upload charts like I showed you and share those out with stakeholders or your collaborators, you could do that. I believe the long-term vision, and Apex has architected the software to go online where you could do actual work with those state classes in the future, but I don't know how long that will be. It requires funding from groups like us to make that happen. Anna, hi.
I worked out where the hand was. A question about validation of those percentages. I mean, it might be too hard because, of course, it's reference conditions, and obviously we're not seeing many of those left in the landscape. But has there been any thought about how that could be done or might be done, or it's too tricky?
Yeah, great question. I'll start with an answer on that, and I'm expecting others will kick in with ideas or brainstorms on that. In the Great Lakes, we would do a little bit of triangulation. So it was just kind of strange, right? So we might have those general land office survey notes, and we might have surveyor account or pre-settlement or early settler accounts, excuse me, and other documentation that would point at initial conditions in more of a narrative way. So we might do some triangulation between those notes and what we think we knew about the ecosystem, the model disturbance regimes, and the outputs, and do some adjustment that way. For example, if we weren't sure if the fire return interval was 100 or 200 years, we might look to narratives to help us describe what we would expect on the landscape and triangulate there. There's also looking at those reference areas, which, as you mentioned, are extremely rare. And there was also what we know about individual species and what perpetuates those species that we would draw upon. But yeah, extremely good question. And I tell people that, to me, this is like a first draft encyclopedia of our ecosystems, and to be refined forever, which may make us all cringe, but yeah, it's really difficult. So with that, I'll open it up to any other comments on concerns, validation, ideas, that sort of thing.
I could add that I've done kind of a deep dive on the validating the fire return interval for dry forests across the West. Some of this work Randy shared on my behalf at a recent Syncrosim conference in Fort Collins. But I calculated fire return intervals taking all the dendrochronology data that's shared in an online paleofire database housed by NOAA, and compared that to what we modeled. And of course, for dry forests in the West, fire is the driving disturbance regime. And so you would anticipate that if you get that fire frequency right, your modeled percents in your succession classes are more likely to be on point as well. And so with the initial results, I felt like our modeled fire return intervals aligned really well with the dendrochronology data. You could see specific areas where perhaps you might want to model a more frequent fire return interval, but broadly across the map zones, I thought we were in the ballpark. But it's a big area, and I would love to hear what other people have done. It's a real challenge to validate a reference condition model.
I can comment on that. Some of you may not know this. We had very passionate modelers at the beginning of LANDFIRE. And there was the famous, it's the Great Basin region sagebrush model. And we nearly had modelers who came to blows with one another in the workshop about what is the natural fire return interval. And I was getting fed up with this discussion that was going nowhere. So I did a sensitivity analysis. And I changed the fire return interval from all the way to 25 years to 75 years. This is stand replacing in that sagebrush steppe environment. You know, it looks like a sagebrush steppe, but it has trees and not sagebrush. And it made a whopping difference of 5% in the reference class, the percentage of the color. So I told everyone to shut up, and we would take the median, and that was the end of the discussion on the thing. So when you do a little bit of sensitivity analysis over issues that people feel strongly about, you often discover that those issues are at the level that we're modeling are not really important. So it's there's some transitions that are surprisingly influential that you don't even think about. And you have to figure out where they are. So there are different ways to do sensitivity analysis on this model, and it's not very complicated. SDSIM is very well set up for that. So.
Yeah, and I want to add, Randy's alluded to this a couple of times, of our interest from our team is trying to figure out how to incorporate like actual traditional ecological knowledge in this, because you know, we have been talking about pre-settlement conditions, but there's a lot of tribal knowledge and indigenous knowledge of vegetation and especially disturbance when we look at indigenous burning. And so there's a lot of knowledge that indigenous communities have just by stories and all sorts of passed down information. And so our team is really trying to think about how can we work with those groups to incorporate that as a sort of additional step of not necessarily model validation, but just like including that information that does exist from pre-settlement. So we don't have that figured out yet, but it's something we're talking about to kind of make these models stronger.
Yeah, thanks for that, Sarah. Definitely. And I like that you tagged on to the validation question with that comment, because yeah, that would be super important. And then great conversation in the chat. Gunnar, I really appreciate that question. It's funny, I think that in my mind, I had this idealized version of how that happened, which is based on ontogenetic sort of things like, oh, the dominant trees became reproductively active, so that's a new succession class, you know, that sort of thing. And I do believe that that did happen some. Also, under best case scenarios, there would be a paper or a framework that we would refer to for ideally even, you know, sets of models. Again, the oak ecosystems and the Eastern United States, there are some kind of standard height cover sorts of breaks that you can use to define the prairie, savanna, woodland, forest classes that are helpful. But yeah, it's a great question, and it varied from person to person. So again, you know, we went with the model of crowdsourcing this, and there's a lot of strengths and weaknesses to that. And one of the challenges is that we don't have like standardized definition or framework for that. Well, thank you all for your patience, for being here, for listening, and for the conversations. Really great stuff. I hope this has been super useful. We'll be back at 2 Central for an afternoon with Corey largely, and summarizing things at the end will be me. And hopefully all of you will join us, and again, keeping the chat and discussion and questions going. So we'll see you in an hour.